Hi guys, I'm Ankit. In this video, we shall see another problem on LeetCode. Product of array except self. So given an integer array, you have to return the array and called as answer such that answer of I, each element and the answer will be equal to product of all elements except that element. So that means, and they have said it's guaranteed to be fit in the 32-bit integer, and you must write the algorithm that returns big of n time without using the division operation. So that means if they are given, let's say 1, 2, 3 for as an array. So for this position, first position, its product will be product of all elements of the array except that element itself. If you do the product of all the elements except that element, it will be 2 into 3 into 4. 2 3 is 6, 6 4 is 24. So you written 24. Again for second position, except to all elements you do the product. So 4 3 is a 12, 12 1 is a 12. So 12 is the answer. Again for 3 also, it will be 1 into 2 into 4. That is 8. Then last element, it will be nothing but 1 into 2 into 3. So that will be 6. But the twist is usually what can be done. If we want this product, first we can find the product of the entire array. So that will give you 4 into 3 into 2 into 1. Right, so that will be 24. If you do 24 for the first position, if you do 24 divided by that element 1, we will give you 24. Next, again for the second position, 24 divided by that element 2, that will give you 12. Similar for 3 and 4 also. Divide by 3 means it will be 8, 24 by 4 means it will be 6. But they have given, we have to use the algorithm with this complexity big of n, and we shouldn't use any division operation. So without using division operation, how do we solve the problem? Because here we are doing the division, right? Entire product we find, then divide it by the particular element. But without using the division operation, how do we solve the problem? That is what we need to see now. So let's write the array first. Let's nothing but 1, 2, 3, 4. Let's come to a conclusion. Let's say if an element 3 is there, what if you find the left sum and right sum? Left sum is nothing but not sum, left product, left array product and right array product. So left array product will be 2, right array product will be 4. So 4 into 2, that will give you answer as 6. Right? So what we'll do, we'll keep an two arrays, left array, left product array and right product array. Okay. Left array, how do we find out? If you have 1, 2, 3, 4, and we need to have left array, right? 1, 2, 3, 4. So how do you find the left product? For this element 1, is there any left element present before to this left element? No. Any element present before to this? No. So just keep the product as 1 for this element. Then come to 2. So when you come to 2, what is the left product for this element 2? There is 1 only. 1. Okay. Next, when you go to 3, what is the left product for this element? 2 into 1, that is something like 2 only. Again for 4, what is the left product? Present 2 in 3 into 2 into 1, that is 6. Similarly, you do the right product also. 1, 2, 3, 4. And then for right product, 4 positions we need. Okay. Now you start from the end of the array. Is there an element present right to this 4? No. So just keep it as 1. Right product be 1. Next we move to 3. What is the right product here? Only 4 is present. 4. Next you move to 2. What is the right product present here? 3 into 4. That is 12. Again you move to the last first position. That is 2 into 3 into 4. The right product is 24. So you could see if you multiply 24 into 1, 12 into 1, 2 into 4, 6 into 1. 24 into 1 is 24, 12, 8, 4 to the 8, 6 1 is 6. So have you got the answer which you had required? 24, 12, 8, 6? Yes. And if you do use any division operator? No. And what is the time complexity? Is big of n? Yes, it is, because n you are taking big of n for this left product, again big of n for this right product, again big of n for this final sum. For final sum, you will be using the product of the respective position elements of the left array and right product array. So this is taking like big of 3n, because it's not big of n into a big of n into big of n. It's big of n plus n, big of n plus big of n. So big of 3n, which is nothing but big of n is a time complexity. So this is a simple approach to solve the problem. And yeah, even if you use a division operator, that will cause a problem, because if you see into this example, the product will become 0 when you multiply any number by 0. And so 0 by something, again if you do 0, that will be a problem. So this is the best way to solve the problem. So nothing but, if you take an element, first you product left sum, right sum. So to get that left sum and right sum, how do you do it? For this element, how do you get the left sum? 2 into 1. So left sum you store in one element, and right sum also you store in one array. Yeah, left sum is stored here, right sum is stored here, and multiply these two. Like 2 is the left sum, 4 is the right sum. So 2 is stored in the left sum array. Sorry, why am I telling sum? I don't know. Yeah, product array. Yeah, and 4 is stored in the right product array. So you just multiply 2 into 4. 2 into 4 multiply, that will give you 6 as the answer. So except 3, all the elements are multiply. So that is how you get the answer. So first, let's say let n be equal to nums dot size, and we'll create array. Okay, left product array, let's say of size n, and let's initialize all the elements to 1 initially. Then similarly, right product array also we have to initialize. Then we'll have a resultant array. Okay, this size also will n only because of the original array only. So first we'll find out the left sum first. For I equal to 0, I less than n, I plus plus. So let's have a variable called left product. So int left product, let be initialized to 1. So first what we need to do, I'll just copy this left product array of I equal to left product, and left product will be equal to left product star nums of I. So what does it mean? As I said, when you begin the element, right, writing from here, is there any left product, any element present left to this? No. So initialize it to 1. That is what? Left product of I, left product of 0 is initialized to left product, that is 1 initially. Then left product equal to left product into nums of I. So 1 will be equal to 1 into 1. So that will be moved to the next position. So we have left product initially 1, that is initialized. Then left product into nums of I. So it will give you again 1 only, because 1 into 1 is 1. Then you initialize that left product of 1. So left product of 1 is initialized to left product. Again left product equal to left product into nums of I. So I is pointing here. So that will become 2. Left product will become 2. That is initialized here. Again 2 into 3 you do. That will become 6, and 6 is initialized here to the next position. Similarly, you calculate the right product also. But in this case, we have to iterate from the end of the array till the beginning. That is one change which we need to do. So I equal to n minus 1, last index, and I should be greater than equal to 0, I minus minus. And here also, instead of left, we should tell it as right. Okay. So next, what is? After this, we have to multiply the left product and right product respective position elements. 24 into 1. First position is first position element. Then second, third, fourth. So final iteration will do. In this iteration, result of I will be equal to left product of I into right product of I star right product of I. And at last, we need to return result. We shall run this. And for Java, the same logic applies, nothing change in the code, only instead of size you mention it length, and the way you define the arrays different over here. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Until then, keep learning. Thank you.